All right, so this is a tan example where we have to think about how the horizontal shift is happening, and this is a horizontal stretch in this case. So let's go back and think about our normal transformations. In this case, my xy is going to become x divided by 2 and y plus 1 because I have a horizontal shrink and a vertical shift. So tangent normally goes through 0, 0. So I'm going to go through 0, 1. Normally I've got pi over 4 and 1. So that's going to become pi over 8 and 2. Negative pi over 4, negative 1. Negative pi over 8. And then 0. And now normally we have an asymptote, a vertical asymptote at x equals pi over 2, but I'm dividing my x's by 2, so that's going to become x equals pi over 4. My period is normally pi, but now I'm going to take that and make it into x equals pi over 2. And so I didn't talk about the period so much. So let's go back and look at our unit circle. So thinking about tan values, I'm wanting to think about how often my slope is repeating. Well, notice that this slope got repeated down here, and this slope was repeated down here. So tan really starts repeating as soon as we cross over the x-axis of my unit circle. So the period of tan is pi because that's when I start repeating. And if I look here, I normally think of it as actually going from negative pi over 2 to pi over 2 as my first cycle. So both on the negative side and the positive side, negative pi over 2 to pi over 2 is one period of tan. So let's come back down here. And now I'm going to start by putting in my asymptotes. So I've got my vertical asymptote at pi over 4. So I'm going to say x equals pi over 4. I'll have the same one at negative pi over 4. And then my period, well, that's just going to keep repeating. So I've made this a total of 4. 1, 2, 3, 4. 1, 2, 3, 4. I can put in my next asymptote. That's going to be pi over 2 away. So I'm going to have 3 pi over 4 is my next one. 1, 2, 3, 4. Over here. My center point, I sort of think of 0, 0 as the center point. That became 0, 1. So if we say that this is 1, I'm here. And now I'm thinking about going a quarter of the way. And normally I go over 1, up 1, and that's still true because I have no multiplier. That also matches with what we said over here, that pi over 8 was going to lead us to 2. And over here, I went over 1, down 1, and now I can just start drawing in my tan curves. It's a bit easier, actually, to make it smaller this way, and then just repeat those 3 points and their distances away from each other. I can go the other way as well. 1, 2, 3. And now I have quite a few tan values to look at. All right, let's look at this one. Oops. So this one, I've got vertical stretch and reflection. I've got a horizontal stretch. I've got a vertical shift. So any point x, y, well, the x's are going to be doubled because I do the opposite. My y values, I'm going to multiply by -3 and then move up 1. So let's think about what's going to happen to my asymptotes. Normally my vertical asymptote is at pi over 2, but now I'm going to double that. My vertical asymptotes are going to be at x equals pi. So let's call that pi over 2, and then I'll have pi here. Similarly, the negative pi over 2 asymptote just became negative pi. So I've got a really wide period. Let's think about that making sense. So normally my period covers an x distance of pi, but now I'm going to double it. My period is going to be 2 pi, and that makes sense because this was x equals pi, x equals negative pi, so I have a whole period. That's a total distance of 2 pi. My normal point 0, 0 stays 0, but now becomes 1. So 0, 1. But now I've reflected and tripled. So instead of going a quarter of the way and up 1, I'm going to go a quarter of the way and triple that value. So I'm going to go down to negative 3. Sorry, I'm going to go triple that value down. So, sorry, triple that value would take you to negative 3, but then also have it moved up 1 because of that. So I can also think of it as going a quarter of the way and then down 3 because I've already accounted for that plus 1 by moving my starting point. So a quarter of the way up 3. If I want to check that, I just think to myself, normally I go through negative pi over 4, negative 1. Well, that's going to become, I'm going to double the x value, so negative pi over 2, multiply by negative 3, gives me positive 3, add 1, gives me 4. 1, 2, 3, 4 is where I ended up. So sketching in my tan curve, I get this shape. And then I just keep repeating. So I'm going to put in quarter point that lines up. And then next quarter point is down 3. Next quarter point would be down another 3. And I continue on like that. Let's do one more. This one has a phase shift. So now my xy, I'm going to take all my x's and add pi over 4. I'm going to take all my y's and add 1. So normally my VA is x equals pi over 2. That's going to become x equals pi over 2 plus pi over 4 is 3 pi over 4. I'm going to think about the left one as well. Negative pi over 2. When I add pi over 4, that's going to give me negative pi over 4. So notice my period is still 1 pi. So my period is still pi. Adding a phase shift does not change the period. All right, my center point has been moved to the right pi over 4 and up 1. So instead of going through 0, 0, pi over 4 up 1, so let's call that pi over 4. And then negative pi over 4 is a VA to 3 pi over 4, another VA. Go over a quarter, up 1 because I have no vertical stretch. Quarter down 1. So I could think about my pi over 4, comma 1 becomes pi over 4 plus pi over 4, pi over 2. 1 plus 1 is 2, so that checks out as well. So drawing in now, my center has shifted. There we go. Continuing my 3 special points, 2, 3, draw in a new VA, and continue the cycle. This time, if I go this direction, I'm starting up top, 2, 3, and there's another VA. So there's some tan graphs for you.